Good morning, madam. I am Sheikh Ghosh Rabbani from AAA section. Today, my topic is equal area, certain area. Introduction to equal area, certain area. The equal area criterion is a graphical method used to analyze the stability of power systems during disturbances. It helps determine whether a system will return to stability after a fault or distribution. This criterion is practically useful in transient stability analysis of synchronous generators. Historical background: the equal area criterion was developed in the early 20th century to improve power system stability assessment. It was introduced by PMN robots and other as a method visualize stability margins. Since then, it has become a fundamental concept in power system energy engineering education and practice. Basic concept of stability. Stability in power systems refers to the ability to maintain synchronism after a distribution. Transient stability specifically deals with the system's response to large sudden disturbance. The criterion provides a graphical means to access whether the system can regain synchronism. Swing equation and power angle. The swing equation describes the rotor dynamic of generator during a disturbance. Power angle, denoted as delta, is the angle difference between the internal EMF and terminal voltage. The behavior of the power angle determines the system stability following in disturbance. Developing swing equations of with formulas. Concept of power versus power angle. The electric output power varies with the rotor angle and is represented as sinusoidal function. During a disturbance, the power angle curve changes affecting stability. The maximum power transfer occurs at a specific power angle, typically around 90 degrees. The equal area criterion explained. The criterion compares two areas on the power angle curve, the accelerating and decelerating areas. If the area representing acceleration is equal to the area representing deceleration, the system is stable. The areas are calculated between the power angle curve and the power line during the fault and post-fault periods. Applying and equal area certainty. The analyze stability plot the power various rotor angle during the disturbance, calculate the areas under the curve before and after the fault clearance. Compare these areas to determine whether the rotor will return to synchronism. Graphical producer procedure. Draw the power angle curve for the system and identify the fault on the and post fault states. share the area representing the accelerating power and the area representing the declarating power. If the areas are equal, the system is considered transiently stable. Limitations and criteria. The equal area criteria assumes a lossless system and neglects damping effect. It is primarily applicable to single machine infinite bus systems. Real world systems may require additional stability analysis method for comprehensive assessment. Practical example. Consider a system specified initial power angle and a sudden disturbance. Calculate the areas under the power angle curve before and after fault clearance. Determine the stability by comparing these areas or according to the equal area criterion. Summary of key points. The area criterion provides a visual method to assess transient stability in power systems. It relies on the comparison of accelerating and declarating areas during a disturbance perspective. Its limitations, it remains a valuable tool in power system stability analysis. So this about all my topic notes. Thank you.